So we ran the kitchen sink as a mobile app using the simulator, and that's great. Before going to Android and iOS, let's try running the app as a desktop app. This will be a relatively simple exercise that can help us understand the more nuanced Android and iOS processes. As I mentioned before, we don't have a real main class. We only have the Bootstrap Codename 1 main class, which we can't run as a standalone app. So we will need to create a new main class, which I will place under a directory called stubs. The term stub in Codename 1 is one we use internally to refer to the iOS Bootstrap glue code. In this case, I place the stub under stubs/desktop/src com codename 1 demos kitchen. There is a bit of code here in the stub, so I'm going to go over the various lines. It's basically a Swing app that embeds Codename 1, so you can enhance the stub with everything available under Java SE. I included import statements because they refer to classes in Java SE, and that might be confusing in the stub. It makes sense to import the implementation code since this code has no portability to other platforms, so I'm importing the Java SE port directly. For simplicity, I hard-coded the app dimensions, but it's pretty easy to create more elaborate heuristics and window positioning using Swing. If your theme doesn't derive from native, this doesn't matter. However, if it does, I made it use the iOS 7 theme, which is the default iOS theme. This will make the app feel a bit more like an iPad app. The Java SE port is used for the simulator too. So things like network monitor and other simulator features might still be on if this is a developer machine. So here we disable all of those flags. This is the location for the storage file under the user home directory. In the simulator, this is always .cn1, but it makes more sense to use your app name for real-world apps. The simulator hides the full file system and shows a fake one under the .cn1 hierarchy. This disables that behavior, so getroots will return the file systems in your machine. The simulator does that by default to make it feel more like a real device. When running on a desktop, you would prefer showing a tablet UI rather than a phone UI. This means that isTablet and isDesktop would both return true. Swing is also single-threaded. This invokes the run method on the Swing thread so we can construct the Swing UI. We create a Swing JFrame and then initialize Codename 1 with the content pane of that frame. These are display properties we rely on in code. They aren't essential, but it's good practice to have them. The frame size is sized and positioned. We bind a window listener for the app close event. We make sure to call stop and destroy on the main class before exiting. Notice we invoke these methods on the Codename 1 thread. We go into the Codename 1 thread to invoke start and init. Once those are done, we call the method again on the Swing thread and show the frame itself. I took a bit of a shortcut by reusing the same runnable instance for both callbacks. Now that this is out of the way, we are nearly done. We just need to compile that code and link it with the Java SE port code. Since we already have an ant build XML file, this is probably the easiest way to do that. I added a new target to the build XML file that looks like this. I want to make sure that we are working with a clean slate when running this build. There are two important things to notice in this statement. I don't use the boot class path since the app is now a standard Java SE app. The class path points at javasc.jar because I'm compiling against an implementation, not an API. Notice that the stubs/desktop directory is added to the compilation process, so that would get bundled too. We copy the theme from the Codename 1 repo, so the native theme will look like iOS. The final step is the executable jar generation. For a jar to be executable, we need the main class in the manifest, which I define here. We need three things in the jar. First, we need the contents of Java SE port, which is already available in the CN1 project. Notice I exclude the skin file from there, as we don't need the simulator and will just increase the jar size. The next thing we need are the compiled sources of the kitchen sink project and kitchen sink stub. And finally, we need the resources defined within the kitchen sink project. So I package them directly from the src directory, making sure to exclude the Java source files. After going through all of this, I now have a desktop app that I can run using this. Notice that this is a self-contained fat jar with no external dependencies, which means it should work well for tools such as Java Packager, etc.